a system for the flight deck, a system for the cabin, a portable oxygen system. The oxygen systems provide adequate breathing oxygen to the crew and passengers in case of depressurization. The flight crew system also provides pure oxygen for use in the event of smoke or toxic gas. The oxygen panel is located on the forward left side of the flight deck overhead panel. Normally, the mask manual on switch guard is closed, the passenger system on light is out, and the crew supply push button is on. The flight deck oxygen system is a gaseous bottle system that delivers regulated oxygen upon demand or can provide forced oxygen. It will provide diluted oxygen upon demand up to a cabin altitude of 35,000 feet, and above this cabin altitude will force oxygen at 100% to the crew member. There is also an emergency feature designed to provide forced 100% oxygen pressure flow to the crew member upon selection of the emergency mode. The gaseous bottle provides oxygen to the 4 quick donning masks in the flight deck. 1 pilot mask and 1 observer mask are contained in separate stowage boxes within 2 covered compartments in the console outboard of each pilot seat. Each crew mask is equipped with a microphone, but the 4th occupant has no transmitting capability. The door Oxy ECAM page displays the unregulated oxygen bottle pressure. This ECAM page will also provide amber indications if the system is off or the pressure is low. The cabin oxygen system is available to all passengers and flight attendants and is separate from the flight deck oxygen system. The cabin oxygen system is a continuous flow system. The amount of oxygen delivered to each mask is very low and is added to the ambient air that is drawn in by the user through valves in the front of the mask. The cabin system is designed for a depressurization event and does not provide smoke protection. The cabin oxygen is supplied by chemical generators that are located throughout the cabin. Each generator can provide oxygen for about 15 minutes to 2, 3, or 4 masks as equipped. The masks and associated generators are installed in containers above the passenger seats, in the lavatories, in each galley, and at each cabin crew station. Cabin oxygen is automatically presented to persons in the cabin when the cabin altitude exceeds 14,000 feet. The cabin oxygen can also be manually presented by use of a switch in the flight deck. The portable oxygen system is located in the left backside of the flight deck. The system consists of a sealed container that contains a smoke hood. The hood is serviceable as long as the yellow indicator on the case is not broken. The smoke hood is designed to protect the eyes and respiratory system of a crew member while fighting a fire, and to provide oxygen if the cabin loses pressure. The smoke hood has a chemical air regeneration system. It regenerates the exhaled air of the user through the regeneration system to make the air breathable. Once the regeneration is activated, it provides air for at least 20 minutes. This completes the introduction of the oxygen system. Next, to answer some questions. Cabin oxygen is provided by chemical generator canisters that are stored in containers along with the associated hoses and masks. There are 2, 3, or 4 masks attached to each generator. The presentation of the masks to the users is provided by opening the container door. The containers are provided in the passenger service units, lavatories, and flight attendant stations. The container door latch is normally released when electrical power is applied to the door solenoid. Automatic door opening is initiated by a signal from an altitude sensing aneroid to all container doors. This automatic deployment of the masks is set to operate at 14,000 feet cabin altitude. Some aircraft have a high-altitude push button that changes the altitude for automatic mask deployment. Selecting the high-altitude landing push button to on changes the automatic mask deployment altitude from 14,000 feet to 16,000 feet. Check your procedures for operating into high-altitude airports. If necessary, a pilot can push the mask manual on push button to manually signal the door solenoids to release. When the door solenoids have been powered to open the doors, automatically or manually, the white system on light illuminates, and the passenger address system broadcasts a pre-recorded instruction of how to don the masks. A single container door can be manually opened by use of a manual release tool. Pushing the pin of this tool into the small hole of the door will cause the door latch to be released. This action may be necessary to open a door that has failed to open via the solenoid action. Note: the system on light will not illuminate if the door is opened with the MRT. The generator is activated by the first person to pull a mask toward their face. Pulling the mask pulls a lanyard to a firing pin. The firing pin snaps to activate the generator. When the generator is activated, pure oxygen flows from the generator through the hoses to all masks. Once activated, the generators create oxygen for about 15 minutes. The amount of oxygen flow is very low, and a majority of the air a person breathes is drawn in through the ambient air valves on the front of the mask. The chemical process generates heat. The surface temperature of a generator is extremely hot, and a burning odor may be detected along with an increase in cabin temperature. The generators should never be touched after they have been activated. The only normal procedure for this system is that during the pre-flight, the system on light is extinguished, and during the cabin pre-flight, all container doors are verified closed. This completes the description of the cabin oxygen system. Next, to answer some questions. The flight crew oxygen system provides breathing oxygen to the crew and observers in the event of loss of cabin pressure or a smoke-filled flight deck. Quick donning masks and their regulators are located in containers as shown. Each mask can be selected to operate in a dilute or demand mode or 100% oxygen mode. When 100% oxygen is selected, the user is protected in the event of smoke or toxic gas. This diagram shows the components and sensor locations of the crew oxygen system. The oxygen cylinder is located in the avionics compartment, and the unregulated bottle pressure is displayed on the ECAM door oxy page. A green oxygen disc normally covers the opening shown in the photo. Two overpressure safety systems can vent the oxygen overboard through a safety port if the pressure gets too high. Therefore, if the cylinder experiences an overpressure condition, most likely a thermal discharge, the green disc will be missing. During the exterior pre-flight inspection, check the condition of the oxygen bay door and verify that the green oxygen discharge overpressure disc is present. A pressure regulator is connected directly to the cylinder that delivers oxygen at a pressure suitable for the users. A supply solenoid valve allows the crew to shut off the distribution system. The solenoid valve is controlled by the crew supply push button. With the push button off and the solenoid valve closed, the white off light in the push button comes on, and the cockpit oxygen label displays amber. Additionally, if less than 50 psi is sensed in the low pressure circuit, the amber regulator low pressure label will display on the ECAM door oxy page. The crew supply push button is switched on before flight. This action causes the solenoid valve to open and allows oxygen to be available to the system distribution manifold. The push button off light goes out when the push button is on. With normal pressure available, the cockpit oxygen label displays white and the amber regulator low pressure label blanks. You can click the crew supply push button on or off and note the effect on the push button, diagram, and ECAM. The unregulated bottle pressure is normally displayed in green on the ECAM door oxygen page. With the aircraft on the ground, if the pressure is below 1,000 pounds per square inch, an amber half frame appears. During pre-flight, this display indicates that you should consult your manual to ensure the remaining pressure is not below the minimum required for the crew and number of observers in your flight deck. If the bottle pressure is below 600 pounds per square inch, the pressure display pulses. If the pressure is below 300 pounds per square inch, the pressure displays in amber and the cockpit oxygen label displays in amber. This low pressure situation will cause the ECAM door oxy page to automatically appear. On this frame, you can press the buttons on the screen to review the indications on ECAM. There are a number of controls and indicators on the stowage box for each oxygen mask. The pressure regulator and its controls are located on the front of the mask. The two red grips, located on either side of the mask, are squeezed to pull the mask from the stowage box and to cause the harness to inflate. We'll describe these before we continue with the pre-flight test of the system. At the top left of the stowage box is a blinker flow meter, which is a yellow cross that appears when oxygen is flowing to the mask. Below the flow meter is the reset test switch. This switch allows the crew member to test the oxygen mask without removing it from the stowage box. Now we show the specific items that are tested when you press the switch. Below the flow, pulling the mask from the stowage box initiates the flow of oxygen and activates the mask microphone. After a mask has been used, you must press the reset test switch to shut off the oxygen flow and to disable the mask microphone. If the stowage box left door is closed when the oxygen is flowing to the mask, an oxygen on flag will appear because the mask is still provided with oxygen. The pressure regulator and its controls are located on front of the mask. There is an emergency pressure selector located at the bottom of the pressure regulator. Pushing the selector will generate a momentary overpressure condition. This feature can be used to clear the goggles of smoke by causing a forced oxygen flow. Turning the selector knob clockwise in the direction of the arrow will lock the overpressure condition to supply forced oxygen continuously. Note, if cabin altitude exceeds 30,000 feet, overpressure supply is automatically started. There is a normal 100% selector located on the upper left of the pressure regulator. Pushing it down will cause the mask to deliver 100% oxygen. This is the position for dispatch. Pull the selector up to return it to the normal position, which provides a mixture of ambient air and oxygen. In normal, the air-oxygen percentage varies with cabin altitude. Above 35,000 feet cabin altitude, the user will breathe 100% oxygen at forced supply, regardless of the switch position. To don the crew oxygen mask, you must squeeze the two red grips to inflate the harness while you pull the mask assembly from the stowage box. Squeezing the grips, specifically the right side grip, causes oxygen flow to inflate the harness. While squeezing the grips, place the mask assembly over your head and use a sweeping motion to pull the mask down over your nose and mouth. As long as the red grips remain squeezed, the harness remains inflated. When the mask is in the desired position, release the grips. When the grips are released, the harness deflates to tighten around your head and the mask will seal to your nose and mouth. Further adjustments can be made by squeezing the grips to inflate the harness, reposition the mask for a better fit, and then release the grips when the mask is in position. As shown here, some masks have a removable protective plastic strip. The strip must be removed for proper vision during use. We now describe the normal procedures prior to flight. If the system is turned off when you arrive in the cockpit, the white off light will be illuminated on the crew supply push button, and oxygen is not supplied to the mask regulators. Pressing this push button will extinguish the light and open the solenoid valve to allow oxygen to flow to the masks. You should confirm the indications on the ECAM door oxygen page. The masks must be tested prior to flight and remain in the stowage box during the test. During the oxygen mask test, you can also test the mask microphone by listening for the oxygen flow sound in the mask. To set this up, 1. Turn on the loudspeakers on the glare shield, and 2. On the audio control panel, press out and adjust the interphone reception knob for the desired volume, And 3. Select the interphone radio switch to interphone. These actions will deliver the oxygen flow sound over the cockpit interphone when you test the mask. Now press and hold the Reset Test switch. The flow blinker shows yellow for a short time, and then shows black. You should hear the oxygen flow sound while the blinker is yellow. While holding the Reset Test switch, also press the emergency pressure selector. The blinker should display yellow and the oxygen flow should be heard as long as the emergency pressure selector is pressed. Release the emergency pressure selector and Reset Test switch and ensure they return to their normal positions. The blinker should blank and the sound should stop. Verify that the normal 100% selector is in the 100% position. Now press the emergency pressure selector by itself and verify that the flow blinker does not display yellow. After all masks have been checked, verify that the regulator low pressure message is not displayed on the ECAM door oxy page. The absence of this message ensures that the solenoid valve is open because the lines remain pressurized after the test. This completes our description of flight crew oxygen. Now for the questions.